This is problem 128 of Neetcode 50 partition levels. So we will be given a strings of lowercase English letters. And we are going to be willing to split the strings into as many substrings as possible within our constraint. And our constraint are that basically a single character cannot appear in more than two um, substrings. So if we take a look at the example 1, we have x, y, x, x, y, z, b, z, and on and on. So in my first string, well, I'm kind of forced to have this x, right? So this means that if I have another x inside this string s, it will have to be contained within this first substring. So you can say the second x that we have in, well, is at the index 2 and the last x is at the index 3, meaning that we cannot go on and create two substrings within these four characters. And notice that within these four characters, we also have a y, and this y is appearing another time at the index 4. So the first substring we can create is going to be containing x, y, x, x, y. Okay, and then we have z. So we're starting with z, and we said we have another z, two index further, meaning that we cannot go on and split these into two substrings. They're going to have to be in the same substring. But notice that we're also containing b here, and b has other occurrence after this. So we are going to have to go all the way and add all the b after this, so that we don't have a b that appear in another substring. And then we have an I, a S, and an L that appears independently, so we can just put them as a substring. And in the meanwhile, we're going to have to return an array with not the substrings, but the length of each substring. So we are going to use a two-pointer QBD approach to solve this, and we're gonna solve this in a time complexity of big O of n. So we're gonna go basically across the line of the string s. Okay, so let's go on a whiteboard to see how we're gonna solve that. So first thing that we want to take into consideration is the last occurrence of each characters. So I will create a hash map basically, and I will go through each characters. Okay, and for each characters, I will set this character's index to be the index that it currently is at. So initially, I will go through x. X will be my key, and x will have a value of the index 0. But then on the second time I see x, I will just reset this x index to be at 2. And then I will see this x a third time. So I will set the x, I will update its value to be at the index 3. So I will keep track in a hash map of the index of the last occurrence of each characters. So what I will do is that when I see basically a first character here, now it's my x, I'll go see in my hash map where is its last occurrence, and I will put a sort of wall here. This is going to be my end pointer. Okay. And now I will just go see the next character, and I will go see if the last occurrence of this next character is greater than the last occurrence, well, the n basically that we currently have. And the n is set here, but notice that the y has last occurrence a little bit further here. So we are going to push back our end pointer. And now we are going to move again. So we're going to go see the x, and the x does not have an end character that is greater than the current ending position. So we are not going to move it. Then we're going to go see the other x, same thing. Then we're going to go see the y. The y is itself the last occurrence, so it is not going to move the entire substring. And in the meanwhile, each time we go see another character, we're just going to add 1. So we're going to have 1, 2, 3, 4, 5. So this is 5. And whenever our pointer reaches the wall, we're going to add in our output array, this 5 here. We're going to reset this counter to 0. And then we're going to start fresh again. But we're going to start from there. So now with our b, which is the first character, we're going to go see where is its last occurrence. We're going to set its last occurrence is right there. So we're going to set a wall right here. So this is like we know that everything that is to the left of this wall will have to be included inside this substring. Okay, so now we're gonna go see the z, and the z is the last occurrence of itself, so it is not gonna move the wall any further. And then we're gonna go see the b, and the b is not gonna move the wall any further because it is itself the last occurrence of itself. So this is gonna have a length of 3. So we're gonna add 3 here. What we're going to do is that we are just going to update our 3 to 0. We're going to start again, and we're going to do the same thing for each of these last 3 characters. And notice that they are all the last occurrence of themselves, so they will be added as one inside our output array. All right, so this is the logic. Now we are going to jump into the code. So the first thing that we will create is a hash map. All right, and now what we want in our hash map is basically the index of the last occurrence of each characters. So I will create a for loop and I will enumerate through s. So I'll say for the index and the character in enumerate s. I will set the hash map's value for this character to be equal to this index. So every time we encounter another character that is exactly the same, this here is going to update its value. So at the end, we're going to keep track of the index of the last occurrence of each characters. Great. So with that being said, there are a couple of things we want to create now before we jump into our two-pointer logic. So we want to create our output array, which is initially going to be empty. And every time that we have a valid substring, well, we are going to add its length into this output array. And now I want to create a variable size, which is going to keep track of the current substring size. And I also want to have our end pointers. Both will initially be equal to 0. And then I can go through every single character. So for, and I will enumerate this. Okay, so I will take the index and I will take the character here. So for this, in enumerate s. Okay, I want to set the end pointer to be the maximum value between what the end pointer currently is and also the last occurrence of this particular character that we are at. So this is going to be a hash map at this character. And one thing we have to do before is also to increment the size by 1 because we are basically moving our pointer to another character. And now what we want to do is, what if the current index is equal to the end pointer? It must mean that we arrive to the end of a valid substring. So what we are going to do is that in our output, we are going to append the current size. And then we are going to set our size back to 0. And at the end, we are going to be able to return the output. And this is going to give us the array that we are looking for with the length of each valid substring. I think I did an error here. Yeah, so I forgot. Let's try this again. Wonderful, so this works. In terms of complexity, when we think of the time complexity, well, we are actually going to go through every single character inside the S. So if we say that the length of S is n, we are going to have a time complexity of big of n. And now, in terms of space complexity, we are going to create a hash map, but the hash map is not going to contain necessarily every single character is inside S. So it can potentially, but it will mainly contain the unique characters, because when we encounter a new character, we are not creating a new space inside our hash map. We are just going to update the value of the key that is already inside the hash map. So at the worst case, our space complexity is also going to be big of n. But if we consider n to be basically the number of unique characters inside our string, this will be more accurate to say that the time complexity is going to be big of m, and m in the worst case can be equal to n. With that being said, I hope you enjoyed the video, and I hope to see you in the next one.